So how do you manage incident response at cloud scale? You could have hundreds or thousands of resources in your environment, and if you try and do it with the console, you're likely to click your mouse enough to void its warranty. My name's James Seward, and I'm a solutions architect at Amazon Web Services, but in a former life, I was a lazy DevOps engineer, which means I like to automate everything I can. Today I want to talk to you about how you can use these tools to automate your incident response. I'll show you an example using the command line tooling and shell scripting, and another one using Python and the Boto 3 SDK. And then I'll show you some next steps that you can use to get started. So why would you use AWS developer tools as part of your incident response? Presumably you've prepared some playbooks and runbooks to handle incidents, and those have actions that your operators are going to need to take in one or more AWS accounts. If you can put those actions into a script, you can save time, both in the lead time for the operator to start responding to the incident, and by making them more efficient when they have a large number of resources that they need to work with. By having this ready to go, you can help your operators avoid mistakes caused by transposing commands from one screen to another, or clicking the wrong thing in the console. It also means that you get to use the same response process for the drills for your incident response as a live event. And also, you can then go on to automate your response by triggering these scripts in response to any alerts. All of these are going to help you save time and move faster when it matters. So let's look at using the AWS CLI and your shell as an example for preparing for an incident. One of our recommendations for preparing is that you make sure the contact information on your AWS accounts is all up to date. This is important in case we need to reach out to you with some security notification or possibly something to do with operations or billing. We also recommend that for your email addresses on your accounts, you use something like a distribution list or a shared inbox, because what you don't want is a single recipient of the notification emails related to your account to then move on to another role or leave the organization, and those emails go unanswered. So let's use the CLI to list all the accounts in our AWS organization. We can then loop through that list of accounts and print the current information about the account so we can verify it. And remember, the CLI isn't just going to be on your laptop. You can take this script and you might run it in something like a pipeline or somewhere like AWS Cloud Shell. The first thing we need to do for this is we need to enable the AWS Organization Service Access to access the account service across all of your accounts. So we use this command to do that. This command is idempotent, which means even if it's already enabled, you can safely run this command again, and it won't make any changes or return with an error. So you can include it at the top of any script that's going to do some actions like this to safely make sure that the environment is configured correctly. Here I'm also using the / character to break my script onto multiple lines. This is partly so it fits on the PowerPoint slide, but this is also a good idea for your actual scripts because it makes them easier to read. If you're holding your scripts in version control, it also makes comparing different versions of the script easier to do, versus trying to spot a single change in a really long command line. Now that we've got that enabled, we can use AWS Organizations to list the accounts in the environment. We just use the Organizations list accounts command on the CLI to do that. And here I'm going to force the output to JSON so that we can see what the structure of the response is, because we're going to need to query and filter it. I'd recommend in your scripts that you include the output option with the specific output format that you want, instead of relying on a configuration file on the host or in the user's home directory. This is because your script might run on a different host with a different configuration file, and then all the outputs would change and break your scripts. The output looks a bit like this. We have an accounts list, and inside that list are multiple objects, each of which describes a single account. The thing we want is this account ID, so we're going to have to write something to fetch that account ID out of the list. The other thing we need to take into account is that accounts can have a status. The status here is active, but it could be something like closed or closed pending, which basically means that you've closed the account, but it's still showing up in the output. We don't want to work with any accounts that aren't active, so we're going to filter the list just for those ones as well. The AWS CLI has a built-in query language that lets you select and filter elements like this without using any external tooling. A popular external tool to do this is JQ, But I'm going to show you how to do it without needing to use that tool using the built-in query language. So we can modify our command slightly to look like this. We've added the query option with this filter string, which I'll explain in a moment. And I'm also setting the output format to text, because what I need for my shell to loop through is just a plain list of account IDs. The query then says that from the list of accounts, I want to select any of the objects that have the status field equal to active. Note the use of backticks here to surround active. This is a quirk of the filtering language. Then from that list of filtered objects, I'm going to select the ID field, which is the one that contains the account ID. And when I run that, I receive a list of all the account IDs that are in my organization, which is perfect for my shell to consume and loop round. Now that we know how to get a list of accounts, let's see how we get the contact information for one single account. We can do that by using AWS account get contact information, and that takes an account ID as a parameter. The output for that is going to look like this, so we can just use that verbatim when we loop through in the shell. But there's something we need to know about this command, and that's if you give it the account ID of the account the command is running in, it will return an error. So what we need to do is detect when we've reached we need to detect the current account ID and remove it from the list of accounts before we start looping over them. So we'd need to modify a list accounts command to something like this. We're still going to query for accounts that are active and then display their identifier. But we're going to send that list through the grep command, which allows us to filter the text. And normally grep would just print matches for the filter term. But by using the -v, we invert the logic of the filter, and instead it will remove any lines that match the filter term. So what we need to do now is programmatically find what the account ID is that we're currently running in. This will make our script portable between different environments without someone having to update it or manually set a parameter whenever they use it. You can programmatically get the current account ID that you're working in with this command, AWS STS get caller identity. And we can see from the documentation, which I've included there at the bottom, that the account ID is one of the several things returned by this command. So we can just again use the query option to select that value straight out of the response and make sure we output in text format. So the output is going to be a single account ID, which is perfect for including in our parameter for grep. So returning to our list command, we can now substitute in the account ID as the parameter for grep. We can use a shell feature where you can use the $bracket syntax to tell the shell to run a subcommand and substitute the output of that command into the first command. So what this will do is it will run the command in green, and whatever that outputs, use it as the parameter for grep. So this command will now list all the accounts in our environment which are active, print their account ID, and remove the current account ID from that list. We can now start to put it all together in a shell loop to work through all of the accounts. So the shell loop is going to look a bit like this, and it's starting to get a bit complex, but we can break it down into a few components. We've already seen the section in pink now in the middle, which gets the current account ID and allows us to use it as a parameter for the filter. The section in green is going to list all of the accounts which are active and then remove the current account from that list. And again, it's in a $bracket syntax so that the output of that, which is the list of account IDs, is used by the for account loop in white at the top of the command. Then, for each account ID that's in that list, it's going to print a simple header, and then it's going to run AWS account get contact information for that account ID. So we can try running that in our sample environment, and we can already see that despite the fact the text doesn't all fit on the slide very easily, the second account in the list has different information to the first, so we probably want to go and investigate that to make sure it's all set up correctly. Next steps for this would be to use, if you like, the AWS account put contact information command to programmatically update the environment with the correct values. If you're using alternate contacts for billing, security, and operational purposes, you can use these commands, AWS account get and put alternate contact, to check and update those. And a feature launch for AWS organizations at the end of last week now allows you to update the root email account, root email address on member accounts of your organization. So let's have a look at how you can do this as well, using the SDKs. So let's say hypothetically that Amazon Guard Duty has detected suspicious activity in one of your accounts. One of the recommendations in this case is to use the IAM credential report to review things like recently created users and users with 2 access keys. We can use Python and the AWS SDK for Python, Boto3, to programmatically download the report and then investigate it based on the logic that we want to use. So the code for that will look like this. Let's step through and look what each part is doing. We start by importing some standard libraries. We've got Python CSV library and the sys library, and then the Boto3 library, which is our SDK. Next, we're going to create an IAM client from Boto3. This is what's going to allow us to call the IAM APIs. The IAM credential report has to be requested in advance, and then it is generated, and then you can download it. So we need to do a little bit of extra logic to work around that. First, we call generate credential report, and you can see the response syntax for that API call here. The state that we receive will be one of started, in progress, or complete, and we can only download the report when it's in the complete state. So what we'll do is check whether the state that we receive back from the API is equal to complete. And if it's anything other than that, we'll just print a message for the user that they should wait a moment and try again, and then we'll exit the script. If you were using this as part of an automated pipeline, then maybe instead you would sort of sleep for a few seconds and then have the script retry automatically. Once we know the report is complete, we can move on to downloading it. And for that we can call getCredentialReport on the IAM API. This will actually fetch the content of the report. And again, you can see the response syntax includes it as this content field. So we just need to get the data of the report out of the API response and into a format that we can work with in code. The code for that is going to look a bit like this. First, we need to fetch the value of content out of the API response. Because we can see that this is bytes and we need to work with a string, we have to use Python's decode method, which turns bytes into a UTF-8 string, assuming it's all valid bytes, of course. What we have then is a single string which contains the entire CSV file in one go with embedded new lines. So we can then use Python's split method on the new line character to break that single line into a list of many strings, each one of which is one row of your CSV file. Finally, we can use Python's built-in CSV support to load that into a variable that we can interrogate. So now let's say, for example, we want to find any users who were created in the last 6 hours. We start by constructing a Python date time and then subtract it, or for now, and then subtracting 6 hours from it, which gives us our watermark. We need to use the UTC time zone for this because all the timestamps in the report will be in UTC as well. Once we've done this, we can simply use a for loop in Python to look at each entry in this report, which is each row of our CSV file. And for each one, we can examine the user creation time and see if it's greater than our limit, i.e. it's newer than 6 hours. If so, we'll print a message that we need to do some more investigation on that particular user. Likewise, if we want to check for users with 2 access keys, we can look to see if access key 1 active and access key 2 active are both equal to true in the report, and if so, print another message that we need to investigate. So testing that in my sample environment, I can see that I've probably got some investigation to do. Moving on from this, you can implement further checks using whatever logic you like in your programming language, and so you might want to do things as look for how recent a password or an access key has been rotated. You can also use other APIs, like list-attached role policies and list-attached user policies, to make sure that the users and the roles in your environment don't have any unexpected policies attached, such as administrator access or the quarantine policy that AWS will attach if it detects compromised access keys. If you find a user with that quarantine policy attached, you will also have an outbound AWS support ticket with further steps you need to follow. And that's why it's a good reason to have all your email addresses up to date so that you receive notification when the support ticket is created. So that was a quick summary of the stuff you can do with the CLI and the SDKs. And really what you can do now is you can take the CLIs and the SDKs to create scripts to go in your runbooks and playbooks to enable your operators to respond faster and hopefully more efficiently across multiple resources and potentially multiple AWS accounts. You've seen how you can make those scripts portable across different environments by auto-detecting things like the account ID they're running in, so that they don't have to be modified specifically for a particular use case. You could also modify the scripts to actually change resources or remediate, but if you're going to do that, I'd recommend that you make the script print the actions it's going to take so that the operator can verify they look safe before they proceed. You can also have it log out the actions that it's performing so that you have a record for either a post-mortem or if you need to have a look at reverting the changes it's made in the future. So what actions in your incident plan can you script automatically? You can use the link here on the right, the sample response framework and resources, as inspiration for things that you might want to conclude in your response plan and things that you could use, playbook actions that you could automate with scripting. If you're interested in the CLI, the link is here. And then the middle link is to all of the different SDKs for the languages that we support. And I'll leave this slide up so that you can grab the QR links. And thank you very much.